Arithmetic sequences. So an arithmetic sequence is a sequence where we add or subtract to get the next term. So if we did 5, 8, 11, 14, ... In this case, we're adding 3 to each time. So that's an arithmetic sequence. But by contrast, if I did 2, 4, 8, 16, in this case, we're multiplying by 2 each time. So that's not an arithmetic sequence. This is a geometric sequence. Now, when it's an arithmetic sequence, that means we're adding or subtracting the same thing each time. We have a general formula for that right here. Something like this. Now, this is a general term of an arithmetic sequence. It will be in your formula sheet. You do get to use it. But let's break down what everything means. So UN, you see right here, that's a term number. So if I was like U3, that means I'm looking for the third term. So my sequence right here, 5, 8, 11, my third term will be 11. So that's a term number. N specifically tells you what term you're talking about. U1 is the first term. So my sequence up there, that'll be 5. My example up here. N, it's just N. So N is whatever term we're talking about, right? So if I was looking for the third term, my N here would be 3. So whatever N you're talking about, these are the exact same letter, the exact same value. So whatever term you're looking for, that also goes there. And then D is called a common difference. That's the thing you add or subtract every single time. So in my example, D would have been 3. So that was my common difference. I was adding and subtracting 3 every single time. Now there's a way to find D if you're not sure, which is U2 minus U1, or actually UN plus 1 minus UN. You get a term to subtract the one before it. But most of the time you just look at it and go, oh, that's what we're adding and subtracting each time. So again, this is our formula. We're going to use that a lot today. And again, that is in your formula sheet. We do get to use it. So for example, first example, consider the sequence 2, 9, 16, 23, 30. Show that the sequence is arithmetic. So we want to show that we're adding the same thing every single time. So nothing special there. You just got to find the common difference. That'll be what? 9 minus 2, so 7. So if we went 2 plus 7, we get 9. 9 plus 7, we get 16. So it is arithmetic. B, find a formula for the general term. So the general term, they do give us a formula already to this guy. Like that. Now, if we're trying to find the formula for the general term, all we gotta do is substitute in for these two values. N has to be left alone because when you want to find the fifth term, you gotta substitute into something. That's our N here. So all we have to do to find the general term is get our basic formula and find the values for U1 and D. Now, based on what we have up here, U1 is 2, and our common difference we found right now, which was 7. That's going to be 7, this will be 2, so I get UN equals 2 plus N minus 1 times 7. Now we do want to simplify this, so it makes it a little easier to work with. So I get 2 plus 7N minus 7, add over like terms. My UN equals 7N minus 5. Or negative 5 plus 7N if you want. So that's my general term. Now part C, find the 100th term of the sequence. Well, easy enough, we have a general term, so if I want to find the 100th term of the sequence, all I gotta do is substitute in 100 for N. So that'll be 7 times, since I substitute 100 in here, because I want the 100th term, I'm going to put 100 in here. 7 times 100 minus 5, so 700 minus 5 is 695. D is 828 or 2041 in terms of the sequence. So the way that works is they want to affect the term of the sequence. They want to affect the UN. So what we're going to do is we're going to substitute these values in for the UN and see if we get a whole number for N or a positive integer for N. Basically, we can't get a decimal or a negative. So that's how it's going to work for D. So for the first one, 828, I'm going to substitute that in for my UN. And see if this actually works and we get a positive N for this. Add 5, 830, 38, 33 equals 7N. Divide by 7. And then I put in my calculator, 119. So yes. The question was, is 828 a term of the sequence? It is. It's the 119th term of the sequence. 2 probably won't work. So let's try substituting this one in. Same idea. So then we're going to add 5, 2, 3, 4, 6 equals 7n. And we're going to divide by 7. Again, if this comes out to not be a whole number, then then it's not a term of sequence. So there's my calculator. 2, 3, 4, 6 divided by 7. And I got a decimal, so it's not. This is approximately 355.1. So no, not a whole number. So no, and cannot be a I should say non-integer, but there we go. Non-positive integer. Anyway, that's the idea. So again, n always has to be a positive integer, or also known as a whole number or natural number. Natural number is better. Next one, consider the sequence 83, 87, 83, 79, 75, 71. Show the sequence of arithmetic. So it looks in this case we're subtracting 4 every single time. So I'm just going to show that. So if I want to find my common difference, it's going to be the second term over the 83 minus 87. So negative 4. I guess if I was trying to show it, I should show that happens more than once. So 79 minus 83 is also negative 4. So D is negative 4. So there's my common difference. We're subtracting 4 every single time. Find the formula for the general term. We did that earlier. So that is un equals u1 plus n minus 1 times d. Again, that is in the formula sheet. You just got to use it. When you want to find the general term, all you want to do is simplify for the common difference in u1. That's it. So my u1 is 87. My common difference is negative 4. So I'm going to get 87 plus n minus 1 times negative 4. And let's simplify this real quick. 87 minus 4n plus 4. Add like terms. un equals 91 minus 4n. So there's my general term. C, find the 40th term. I think that's an easy one. So we just got to substitute in 40. So u40 just means substitute in 40. 41. 40th, I should say. So I get 91 minus, that's 160, so that's going to be 69, negative 69. So that's C. D, which term of the sequence is negative 297? So I want to know what term is, so they're telling you it is a term, but they want to know which one. So just kind of like before, we're going to substitute in for our un. So that's what this is. So that we're going to substitute in for our un. We're going to find end. So we're going to get to our general form right here. And in this case, we're going to substitute in negative 297 for un. So negative 297 equals 91 minus 4n. Subtract off negative 91. And we get, what's that, 8. Negative 388 equals negative 4n divided by negative 4. And then equals 34 goes to that 9 times, so 6, so 28. That would be 7. So 97. So that'd be the 97th term. Next one. Prove the sequence arithmetic. Now, so this time it's a little different. They gave us this. So prove the sequence arithmetic. We actually got to find our first term, our second term, and probably our third term to show that it's arithmetic all the way through. So our first term is plug in 1. So 71 minus 7 over 2. That equals 64 over 2, which is 32. So that's our u1. Our u2, so 71 minus 7 times 2 over 2. So 71 minus 14 over 2. So that's going to be, what is that? It's 57 over 2. Which equals 28.5. So that's my second term. Now the reason I'm going to do third term because I'm not sure. Like it looks like I'm adding or subtracting 4.5, but it could very well be some ugly fraction. So we have to find the third term. So 71 minus 7 divided by 3. See if it does the same thing to all 3. So that's going to be 50 over 2, so 25. So it looks like it goes, what, down 3.5 minus 3.5. So it looks like common difference here is negative 3.5. So 32 minus 28.5. So negative 3.5. other way around. It should be u2 minus u1, not u1 minus u2. Remember, it has to be a negative because we're subtracting. So negative 3.5 is my common difference. So find the first term, find the common difference. We did that already. This is 32. This is negative 3.5. Now find u75. Well, to do that, I think it's probably easiest to write the general formula. So it's un equals u1 plus n minus 1 times d. So again, we know what a u1 is. It is 32. So 32. Common difference is negative 4.5. Now, since all I want is the 75th term, I can just substitute in 75 right now. So it's be 75 for n. So I get u75 equals 32 plus 74 times negative 4.5. Now, I'm going to use my calculator again because I don't know what that is. So 32 plus 74 times negative 4.5. And we get negative 301. So that's the 75th term. The 75th term of sequence is negative 301. For what values of n are the terms of sequence less than negative 200? So they're saying, hey, what values of n? So they want to know when is un less than 200, negative 200? Well, we need our formula, and our formula is right. Well, I should have found it. Right, our formula is, I should have done it up here. I'm running out of space. Un is u1 plus n minus 1 times d. I should have found this earlier. This is 32, and this is negative 4.5. So if I simplify this real quick, this kind of sucks. Plus negative 4.5 n plus 4.5. So my un is 36.5 minus 44.5 n. Okay, so that's my general formula. And now I just got to set that less than 200. So 36.5 minus negative 4.5 n is less than negative 200. Now all we have to do is solve this. So subtract 36.5 from both sides. I get negative 4.5 n is less than negative 236.5 divided by negative 4.5. And again, use my calculator for that because I don't know what that is. Negative 236.5 divided by negative 4.5. And I get 52.5555. Which is not a normal term. Oh, that's not the question. Okay, yeah. Sorry. So a couple things. N has to be greater than, since we're dividing by negative, we switch to inequality. What did I get? I'm just going to round it. 52.5. 50.6. Now, again, what the question was. So the question was, what are the values of n which the terms are less than negative 200? So the terms greater than 52.6, again, we can't do decimals. So the terms that are greater than 50, greater than or equal to 53. So any term that's greater than or equal to 53 will be less than negative 200. Or I guess we could have gone the other way and said, is all terms greater than 52? Because once you're greater than 52, then it's all going to be less than negative 200. So either way it works, this or that. For the next one, find k given that 3k plus 1, k, and negative 3 are consecutive terms of the arithmetic sequence. Now, if they're consecutive terms of the arithmetic sequence, like how can you use this to our advantage? Now, in an arithmetic sequence, let's go find one up here. There we go. Right? Since these three are consecutive, if I go 9 minus 2, I get 7. If I go 16 minus 9, I get 7. Right? The difference between any two terms is a common difference. And we're going to use that to our advantage here. So if I do, this is like u1, u2, u3. I don't need to write that, but then I do k minus 3k plus 1. Don't forget the parentheses. It should equal the same thing as negative 3 minus k. Right, like if you're trying to find the common difference, it'll be this guy minus this guy. And then, or you can do this guy minus that guy. That's the way it works. It's always, your general form for the common difference is un plus 1 minus un. Right, the second term minus the first term, or the third term minus the second term. So we just have to set this up and solve it. Shoot the negative. K minus 3k minus 1 equals negative 3 minus k. Add up like terms. This is negative 2k minus 1 equals negative 3 minus k. Put the numbers on one side and put the variables on the other side. So I'm going to add k, so add 1. Actually, the way around. I'm going to add 3 to both sides. And I'm going to add 2k to both sides. I like keeping things positive. So these are gone, these are gone. I get 2 equals k. There we go. K equals 2. Remember, when things are consecutive features, that means you can find the common difference between them. So I subtract this from that, or this from that to find the common difference. And the same thing here, I can subtract this from that to find the common difference. Example 4. Find the general term un from an arithmetic sequence with u3 equals 8 and u8 equals negative 17. So this we have to write 2 equations. So we're going to write one for this guy. So remember the general formula is this: un equals u1 plus n minus 1 times d. So what goes on here, we don't know what u1 is or what d is. So what I do have is I have these guys. So let's set them up by plugging stuff in what we know. Look what it says. The third term, when you substitute in 3 here and here, it equals 8. So when I plug 3 in, it equals 8. So you can kind of think about it this way if you want. Oops. 3, right? When I substitute 3 in, this guy equals 8. So I'm just going to plug that in like this. This is 2d. So I get this formula. I can do the same thing with this one right here. When I substitute in 8 for n, it equals negative 17. So I'm going to skip that first step I did last time. Kind of. u1 plus 8 minus 1 times d is an 8. I'm going to simplify this a little bit. Rewrite it and I get negative 17 equals u1 plus 7d. Right? So in this problem, they didn't give us the u1 or the combination or sequence. They just gave us these two terms that we knew about. So what we do is we plug them into the equation. Simplify a little bit and I get these two guys. And look what happens. I have two equations, but I also have two unknowns, u1 and common difference d. So if you have two equations to unknowns, you can solve it. Elimination, substitution, any way you want. So let me rewrite them. Oops. So since we have our two equations to unknowns, we can solve it any way we want. Now look at the u1s are almost identical, so I'm going to multiply. I like to multiply by things. I'm going to multiply the top row by negative 1. So I'm going to get negative 8 equals negative u1 minus 2d. Negative 17, keep the bottom the same. It's u1 plus 7d. Again, I like to subtract rows. I just like to multiply one row by negative and add to make it easier. So add these guys down. I get negative 25. These cancel, and I get 5d. So then we just divide by 5. And d equals negative 5. And like every two equations to unknowns, once you get one variable, don't forget to solve for the other one. So you can go back and plug this into any one of these two equations to solve for it, or any one of these two, same thing. I'm going to use the one that looks more basic. So I get 8 equals u1 plus 2 times negative 5. So 8 equals u1 minus 10. Add 10 to both sides. And I get u1 equals 18. So I have my u1, I have my common difference d. Let's make sure we know what the question was. Find the general term. So we want to put the general term in. Now again, we found u1 and d, so we just plug it into here. D is negative 5 and u1 is 18. So my formula is 18 plus n minus 1 times negative 5. Again, I could leave it like that, but if I want to make it look a little nicer, I'm going to distribute real quick. Takes me 2 seconds. And I get un equals 23 minus 5n. And that's how I do it. When they don't give you the first term or second term, anytime you're missing stuff, the general rule is to go back to the general formula and plug your stuff in. In this case, I have to plug both of them into my general formula. And once I do that, I get two equations to unknowns, and it's just solve it any way you like. Example 5. Insert 4 numbers between 3 and 12 so that all 6 numbers are in an arithmetic sequence. So let's say we have 3. We're going to insert 4 numbers. 1, 2, 3, 4. Then we have 12. Now keep in mind, it is an arithmetic sequence. So what does that mean? Whatever a common difference is, that's how you get the next term. And if you have an arithmetic sequence, all you have to do is add the common difference to get the next term. So you could say this is 3 plus d. Now if I add that to the next one, I get 3 plus 2D, right? Because you're adding another common difference. Another common difference, and you get 3 plus 3D. Do it one more time, and you get 3 plus common difference, 3 plus 4D. And actually, you have to do it one more time because I want to figure out what this guy is. Right, to get to here, you add another common difference, and you get 12 is also known as 3 plus 5D. So that's how we're going to solve this. So I know there's 4 spaces in between. I started at 3. It's an arithmetic sequence, so all you're doing is adding the common difference. So whatever common difference is, we'll say D. This is 3 plus D. Then you add another common difference, you just go 3D plus. Basically, right here we're going 3 plus D plus another D. Well, you add left to like terms, and you get 3 plus D, 2D. Do it again, 3 plus 3D, do it again, 4D, do it again. This guy equals 3 plus 5D. And that we could solve. Minus 3, I get 9 equals, this is not going to be pretty. Divide by 5, and I get 9 over 5, so what, 1.8 equals the common difference. I really wish they didn't make it a decimal, but how else are you going to add 4 numbers in between 3 to 12, make it nice and even? But that's the idea. That's the common difference, but the question was basically find all numbers. So now that we know the common differences, I can find all these. So this is 3, first number. Then we're going to add 1.8 to that and get 4.8. And then we're going to add 1.8 to that. And I get, what was that, 6.6. Add 4.8 to that, 1.8 to that. I'm basically adding 2 and subtracting 0.2. So that'd be 8.6, 8.4. And then add 1.8 to that. We're adding this one. And I'm going to get, what was that, 10.4 by 10.2. And then if you add 1.8 to that, you get 12. So it was the right answer. And here they wanted. Okay, last one. Ryan is a cartoonist. His comic strips have just been bought by a newspaper. So he sends them 28 comic strips he has drawn so far. Each week after the first, he sends 3 more comic strips to the newspaper. Find the total number of comic strips he sent after 1, 2, 3, and 4 weeks. So after the first week, he sent what, 28 originally, plus he sent 3 more. So that is 31. After the second week, well, he sent so far 31, but he sends 3 more. So that's 34. And the third week, right, he sent 34, but he adds 3 more. 37. And then the fourth week, 3 more to that. And he gets 40 in total, right? So that's what we sent in total. Show that the number of comic strips sent after n weeks forms an arithmetic sequence. So when they want you to do that, you generally just got to find the common difference. And the common difference here is going to be 34 minus 31, which is 3, and I'll show the same thing for 37 minus 34, which is also 3. So that's my common difference. So it's an arithmetic sequence. Find the total number of comic strips sent after 15 weeks. So again, a good way to do that is to write the general formula. Equals u1 plus n minus 1 times d. Common difference is 3. Our first term is actually 31 here, right? That's after the first week. That's our first term. So if we simplify that, it should be the 3n minus 3. We get un equals 3n plus 28. So that's our general formula. They want us to figure out, find the number of comics sent after 15 weeks. So this one, substitute in 15. So we get 3 times 15 plus 28. So that's what, 45. 45 plus 28. So that is 73. So you sent out 73 comics in total after 15 weeks. Proper answer. When does Ryan send his 120th comic strip? So again, we're going to substitute in 120 for our UN, for our total amount. So for D, let's go to the general formula right here. We're going to substitute 120 in for UN. We're going to solve for n. So subtract off 28. You get 92 equals 3n. Divide by 3. It's not going to work out nicely. I'm going to do this by hand this time. So 3, we get 9, 0, bring down the 2. So 0, and 30 and 2/3. So 30.67-ish. So when does he send off his after when he sent his 120th comic after 30 weeks. So after 30 weeks he sent off, because at 30 would be a little bit below, but once you get past 30 we're above. So after 30 weeks he sent off his 120th comic. There we go.